All right, we're going to do something that you already know how to do. And so the question has to be, why am I teaching the same thing we just learned a little while ago and calling it something different? Because what I'm doing is technically different, although the way you do it's exactly the same. And there's the confusion right there. Okay? There's the confusion right there. So, starting off, I might look at this and say, I've got the point 2 plus 3 on Mr. Miranda. How would I graph that point for starters? 2 this way, in the real direction. And 3 in what we're now calling the imaginary direction for lack of a good name for it. Okay? Already did this before. That was easy enough to plot. Now, what if I wanted to write this in a slightly different way? I certainly could, right? I could write this point a number of ways. Let's write it polarly, shall we? How would I write it polarly, Mr. Miranda? Like the polar means r and theta, right? Measuring it r and theta, agreed? So how would I go about that, sir?
So 2 and 3.
So it'll be 2 and 3, but it's not 2 and 3. I need an angle and how far it is. So how to describe how far it is? So you're going to do angle first? You want to do angle first? Okay, so we'll do angle first. So tangent of theta is equal to, wouldn't it be 3/2 because it's opposite? So 3/2. So theta becomes the arctan of 3/2. Can you do me a favor? Can you figure out what that is in terms of degrees? 56 point what? 56.3. Math's not good for you, huh? All right. I am. I totally am. Till you're 18, I can be a bully. Moving on. What do you got? How do I figure out how far r is? Mr. Miranda. How do I find the length of the hypotenuse? Pythagoras. So I'm going to go 2 squared plus 3 squared equals r squared. And so I get 13 equals r squared, or r equals plus or minus root 13. Sorry. We agreed we're not going to use the negative version, so it would just be, so the polar version of this would be root 13, comma 56.3 degrees. Agreed? That would be the same exact spot. What if I were to ask you, sir, what if I ask you, could you write this in terms of components? Like a vector. What would x be? And x would be 2, wouldn't it?
Oh. Yeah.
But I could also write it as r cosine theta, right? So I could write this x as r cosine theta. And since we already found r and theta, I could write x as root 13 cosine of 56.3 degrees. Agreed? By the way, put that in your calculator, see if we get 2. We should get 2, right? Okay, let's try y. What would y be by that same reasoning? Ms. Miranda, what would the equation for it be?
It would be square root of 13
sine theta, love it. Sorry, yeah, sine 56, or sine theta, which would be y equals root 13 sine of 56.3. So I'm running out of space if everybody can see that. Everybody's okay? At least hear what I'm saying? Okay, and by the way, what would that be? 2.9, or darn close to 3, right? Probably a rounding error in the 56.3 degrees. Great? Okay, so that's interesting. So I can write this a third way. Oh, man. What do I mean by that? We started with 2 plus 3i, didn't we? Couldn't I write this as root 13 cosine of 56.3 degrees? Right? That's the 2 in the x direction, right? Plus, I want my 3. What's my 3? It's this one here, right? Root 13 sine of 56.3 degrees. Oh, I still need an I, right? Isn't this the same as this? Now, the obvious question is, why would I ever do that? That's just ridiculous. But I'll explain that later. But isn't it not the same thing? So this is, although it has an angle in it and it has an R in it, this is rectangular form. It's that, right? It's the form we dealt with last year. We call that rectangular, right? 2 and 3. So that's interesting. Now, are mathematicians lazy like everybody else? No?
Yes.
One of the best reasons to do math is to be lazy, right? Because then you don't have to work as hard as everybody else who's not good with math. So we take a look at this and we go, all right, is there another way to write this? Let me write this another way because we don't want to write this way every single stinking time. So see this root 13 and that root 13? That's in both of them, isn't it? So all right, root 13 out in front. So far with me? And then isn't this angle the same? Isn't this angle the same? And if I do the same process every single time, I'm going to get the same angle for both of these, right? Because we're talking about this angle here, aren't we? So I'm going to rewrite this as cosine the angle plus sine the angle I. Cosine plus sine I, or I sine, right? So cosine plus I sine. Cosine plus I sine. So if somebody can say, I'm just going to write cis. What does that mean? Cosine plus I sine of 56.3 degrees. So that's another way to write the same thing, less letters, and mathematicians are lazy like everybody else. Got it? What is this thing? It's exactly the same as this. This is exactly the same as that.
What is that form called?
We call this Cis form, which is cosine plus I sine form. Yes, sir?
Why not just make it one vector?
We need one vector.
Well, couldn't you combine those two? 13 root cosine of 56.3 and root 13 sine.
Because the I on there, can you add those up?
Oh, I guess you can't.
Can't. Yeah, basically, it's always going to boil down to end up right back over here, but that's kind of weird because the only real question you should have right now is why do this? And I'm not going to answer that for a whole other worksheet. So what I want to do is I want you to do number 4. Number 4 is 3 plus 4i. I want you to figure out what the cis form of that would be. This takes you longer than 2 minutes. You're probably doing it the wrong way, which makes sense because I showed you the wrong way. Maybe should I do the first one?
Yeah.
Let's do the first one. Let me show you. Now, everybody got the idea? This is the same as this? Right? Here we go. Let me do it this one. I'll do 4 for you. So it's 3 plus 4i. So I'm going to sketch a quick graph. By the way, those of you that stop sketching graphs, you'll pay the price. This is on. With me?
Wait, one of these is negative.
Are you with me? Mr. Zong? I'm saying it wrong? Let's say your name again. Zong. Sorry. Zong. You with me? Sort of? Okay, then come in. Okay, but come in before first period because I got first period calculus. Or come in during lunch, come in after school, okay? We need to get caught up. Okay, so how do I figure out what this R is? Pythagoras, right? So I'm going to go 3 squared plus 4 squared equals R squared. That's 25 equals R squared. R equals plus or minus 5. We ignore the fact that 5 is positive or negative because it's hypotenuse. We're going to make it a 5. Good? Okay, so R is 5. What's my angle? How do I find my angle? Tangent. Theta equals 4/3. Theta equals arctangent of 4/3. I'm going to have to put in my calculator, so get out your calculator, punch it in there, see what we get. What?
53.13.
53.13? That's my angle. Now, what I've done is totally illegal and moral and wrong. This is how to find my polar, right? But I'm going to put it in my RCS form. What's my RCS form going to be?
Yeah.
Radius,
Yeah, 5, 6, 1.
cis, 53.1 degrees. And I'm done.
So 6.1 is
Point one.
cis.
R cis theta. But it's technically not polar, which is really odd because we use polar coordinates to figure it out. I apologize, but trig is always odd. You guys got it? That's not polar. That's technically rectangular because if I were to put the 5 back in, if I were to write this 5 cosine 53.1 plus I sine of 53.1, I would get back to 3 plus 4i. Like that. All right, that's good. Work on the worksheet.